All right. So introduction to nutrition here. This is our first day. We're going to be talking about some of the main concepts as we kind of go through this whole class as it relates to understanding the basic components of nutrients, what that means. And then we're going to trying to translate that information into stuff that's easy to understand for our clients. That's honestly the hardest part of nutrition. I often think that nutrition is actually pretty easy to understand, but doing it is hard, right? Like doing it properly is the difficult part, right? The understanding of it, honestly, it's a little bit of chemistry, a little bit of biology, but for the most part, it's it's just one of those things where it's almost like it feels like a trick question. When you I'm sure everybody can do this on a test at some point, right? You'll be answering questions on a test. And you're like, yeah, that's the answer. But then there's that little voice in the back of your head and you're like, oh, maybe that's not the right answer. And then you start second guessing yourself. And then all of a sudden you're like, oh, well, now I don't know what the answer. It's like, you knew it. You knew the right answer. We all kind of know how to eat healthy, right? For the most part, it's hey, get some fiber in your diet, try to get some greens in your diet, watch your calorie intake, be physically active, right? It's not really that difficult to lead an active, healthy lifestyle with good food and stuff. What's difficult is noticing whether or not you're doing it properly or if you're actually just doing it in general. That's the difficult, actually applying it is the hard part, there's a joke by John Mulaney that I love where he's talking about he's talking about when he was on the basketball team as a high schooler, and he says to the audience, he goes, my body is really bad at sports, and everybody laughs, and he goes, and what I mean by that is my brain is good at sports. My brain understands how a person can dribble down a basketball court and make a layup. But my brain has to outsource the work to my weird, awkward body. And it's I kind of feel that's how nutrition is for a lot of people, right? Your knowledge brain understands what it means to live an active, healthy lifestyle and eat properly. But it has to outsource the job to your personality and your lifestyle. That's it has to outsource it to the conscious sort of everyday part of us that's well, I know I shouldn't go to McDonald's, but it was a hard day today and I'm a little tired. I don't feel like making dinner. I don't know. I'm not a parent. I don't know how parents don't go to McDonald's every day. To live a very busy life and then have to go home and try to make a healthy dinner. That's a lot of work and it's very challenging, I don't know how people do it. Hopefully I'll figure it out someday, but I think that's a big part of what our job comes in, right? We are here to help our clients translate nutritional information into lifestyle choices that are easy for them to adhere to, because adherence is really the big deal with nutrition. You're going to hear me say that a lot throughout this whole class. We're going to be talking a lot about how, honestly, the big thing is adherence. So this class is really built around the idea of sports nutrition, which might make it sound like you are, only dealing with nutrition as it relates to athletes and stuff. That's not necessarily what we mean. When we say sports nutrition, we just mean that it's a specialized area of nutrition where, yeah, we are going to talk about maybe because someone is lifting weights, they need a little bit more protein in their diet. Now, that being said, more protein doesn't necessarily mean more muscle unless they were not getting adequate protein before, or how many carbohydrates somebody needs. People ask me all the time, they're like, should I do low carb? And I hear low carb is really good. It works for a lot of people. Should I do keto? And it's I'm not against keto, but I think that it can inhibit your progress if you are also trying to be very physically active, because carbohydrates are a really good source of energy that make you more effective in the gym. But if you're on a keto diet, you're not really getting any carbohydrates. You're missing out on that improved capacity. Now, if you're just maybe like doing like low intensity walking or, things like that, then yeah, I think keto can actually be pretty effective. Low carb might be the way to go because like you're not really emptying out your glycogen stores as much as an athlete would. So there's no reason to like stock them up, you know? Um, so I do think that like there are some adjustments to be made, and we will be talking about like fad diets and things like that at some point as well. But that's what I mean when I say sports nutrition. It's like, okay, we are going to partner closely with like exercise when we are talking about nutrition. But our conversation is going to be centered around not just like, what's the best diet, right? That's the question everybody always asks, right? Like, I'm sure you guys have probably experienced this because you're like, oh, what are you up to? And it's like, oh, I'm going to school for diet and exercise, and then they're probably like, oh, what's the best diet I should do? What's the best workout I should do? And it's like, honestly, though, it's kind of a flawed question. When you ask it that way, it's like there really is no best diet. It depends, and I know that it depends is everybody's least favorite answer to a specific question, but honestly, it's the most accurate answer, So we're focused on fueling physical activity with sports nutrition. We're focused on repairing the body in sports nutrition. And we are all about optimizing performance because optimized performance is going to translate to the best results for our clients. So that's the area. That's what we're focused on over the next 8 days. We want to help our clients understand that as well. We want to translate this kind of complicated area of science to nutrition properly, right? We want to give our clients a basic understanding of how nutrients are going to operate, but we also want to have like how to apply that to an everyday lifestyle. So like, for instance, here's a great example. Would you guys rather have a client who does a diet program that you put together perfectly? Like they just adhere to everything it is that you said they could do. But the whole time while they're doing it, they don't really enjoy it. They're kind of stressed out. They're having a really hard time sticking to it, but through sheer force of will and effort, they stuck to the program. Or would you rather have someone who like adopts a very similar program nutritionally to what you gave them, but maybe they fall off the wagon here and there. They go to a birthday party and have some birthday cake, and they're like, oh no, I missed my workout because it was my friend's or it was my high school reunion, like something happens and they fall off the wagon a little bit, but they follow the program, I'd say 80% of the time. And that remaining 20%, they kind of fall off a little bit, right? Which client would you rather have? Question, just out of curiosity. What do you think's better?
The one who falls off and gets back on.
Honestly, yeah. Because it's like 80% of the time they're doing really well. The other person, they followed it 100% of the time, but like they're just miserable and they're not going to sustain that. At some point, they're going to crash. They're going to experience burnout and they're going to fall off of it, which means that like, honestly, it's kind of a trick question in a way. It's not really a perfect program because there really is no perfect program, but people want the perfect one. They'll ask you all the time, what's the best diet? What's the best workout? What's the best this, right? So there's kind of a lot going on there, and nutrition is very complicated sometimes. It's important for us to kind of understand all that and have like a good way to kind of break that down and translate that to our clients, which obviously can be kind of difficult. So whoops, too much. There we go. So one thing I want to cover really quickly, just before we get into the sort of how to do it and stuff, is I want to give you a breakdown here on what our role is, right? So I want you guys to keep this perspective with you as you continue talking about like diet and exercise in the uncommunity. And remember that like this is true for me as well. We are what is called an evidence-based practitioner. Eggs used to be really bad for you. They're like, eggs, I got so much cholesterol, right? And then eggs were fine, right? And then eggs were bad again. Then they were fine again. It's like, what the heck, Well, the reason that shifts so often is because we are an evidence-based practitioner, right? We are relying on like guidelines that have been observed as being like safe and effective. But, you know, every experiment's going to have some gap in how perfect it is in relation to like large scale populations. What might work for me might not work for you, or what was observed in one person might not be observed perfectly in another. You know, like I'm doing this like COVID study right now where like they gave like an alternative to a booster, was like a pill version. And like, you know, what's funny about that is like I did it because like it pays really well. But like and I needed my booster. But here's the thing, I'm probably going to get a regular booster shot once I'm done with this study. Which seems kind of weird because it's like, well, wasn't that supposed to be your booster? And it's like, here's the thing, it's a pill form. And I think this is just true for me. I think that like one weird thing about me, it's very rare that I get food poisoning. That sounds kind of like a weird thing to say, but I just haven't dealt with it that much in my life. And like, I'm sure I've been exposed to the same amount of like bacterial problems that other people have, but I also don't really get, I talked to my dentist, I don't get cavities. And he was like, well, probably the reason why is because you have like really strong enzymes in your spit. And I was like, oh, I know all about enzymes. I was like, that makes sense. That information translates. And he's like, yeah, it's probably true of your entire digestive system. I was like, you're probably right. So anytime like bacteria gets in there, it probably just gets eaten up and destroyed. I doubt that those pills are going to survive, you know, and they're going to make it into the bloodstream the way they're supposed to, which is why when this is all over, I'll probably get a regular booster shot. But that is the thing. I'm like kind of a weird outlier, right? Now, if somebody observes that and like they realize that like, oh, this person's an outlier, now they have new evidence to say, hey, this is going to be effective for some people, but maybe not. And that's where our recommendations start to change. We start to observe more people doing something. Chances are when they thought eggs were bad for us, it actually might have been like the original study. That was probably true of how they observed it or what they were looking for. And now they're saying, oh, that's probably fine. That's probably also true. That's what's difficult about nutrition. Evidence-based practice can be very difficult because you'll observe certain things. We used to think that 3 sets of 12 was the perfect rep and set scheme for literally every client out there. That's what we used to think. 3 sets of 12, everything. We used to think that was perfect. And that's not necessarily untrue. It was perfect for a lot of people. But then we started realizing some people need to lift a little heavier than that. Because strength can actually be a really great way to gain muscle. Some people need to lift a little lighter than that. Started to see like then we shifted and started thinking that like low reps are the best way to build muscle. And now they're finding like, well, certain high rep routines actually do have some very good muscle building capabilities. So who was right? Who was wrong? Honestly, the answer is everybody was right. Everybody was wrong. That's what evidence-based practice is. So I've got a really fun video to show you guys right now. This is actually a sketch. This is actually a joke. None of this is scientific. It's not meant to really teach you anything, but I do think that it has a really good perspective. It is going to help you understand the perspective of why nutrition can be so confusing. Let's see here. So this is called the time traveling dietitian. It's going to kind of break down like, you know, if we could travel through time, what is very good for us and what is very bad for us. So I love this video. I show this I show this in the first day of nutrition every time. Okay.
Oh, you're terrible.
Wait! Stop! Don't eat that food!
Who are you? What are you doing in our house?
I'm from the future. I'm here to warn you, don't eat that food.
Why not?
The eggs, they're full of cholesterol.
What?
Cholesterol, it clogs up your arteries. Eating even just one egg can dramatically increase your chance of heart attack. Don't eat eggs.
Oh my God, thank you.
You're welcome. Godspeed.
guess I better take those eggs.
Wait! Stop!
You're back!
Yeah, we were wrong about the eggs.
How?
Well, it turns out there's two types of cholesterol. There's good cholesterol and bad cholesterol, and eggs actually have both. So you can eat eggs, but just don't eat the egg yolks. So stick with the egg whites.
Yes, thank you.
Yeah, Godspeed. Wait! We were wrong about the eggs.
Again?
Yeah. Yeah, okay, so it turns out that the amount of cholesterol in a food doesn't actually affect how much cholesterol ends up in your blood. The eggs are probably fine. In fact, we sort of don't even know what cholesterol is. But the steak! You can't eat the steak!
Why not?
Turns out that red meat increases your chance of heart attack. You have to cut out red meat. So no steak!
Thank you.
Godspeed.
Like the early 2000s
What?
right there.
No steak, mister.
What?
Wait! We were wrong about the steak.
Ah!
It's the toast. Man was not meant to eat bread.
What do you mean man was not meant to eat bread?
Well, if you think about it, human beings should really only be eating what our Paleolithic ancestors ate. So, therefore, no bread, no toast.
How do you know what our Paleolithic ancestors ate?
Well, we just have to guess, right? I mean, we don't have any way of knowing. Whew. Okay. Went back to the Paleolithic. They are not doing well. I don't know what we were thinking. If anything, we should all be eating a lot more bread.
Ah!
Jeez. So I guess just ignore everything I've said and exercise.
Exercise, okay.
Yeah. Yeah, you guys could probably use it. You've been just sitting here for the last 35 years.
It's been 5 minutes.
Right. Time travel. All right, well, Godspeed. Turns out it's genetic. Doesn't matter whether you exercise or what you eat. I'm sorry I ruined your meal.
I need 10 minutes.
Do you want some eggs?
I'd love some.
So, chances are we are all the time traveling dietitian. And things are changing all the time. So there's no real perfect answer when it comes to nutrition. So keep that in mind as we move through this course. We'll be giving you guys general information that we know for sure about biological molecules, but the effects they have on us, you know, that information changes consistently. I will give you the most up-to-date, what we think right now examples. And in 5 years, it could change. And you're going to think back and be like, man, Brad was so wrong about all that stuff. And it's like, well, I was right at the time. So, all right, so let's take a little bit about nutrients again. I know we've broken this down a couple times, but I'm going to kind of draw like a little big chart here. So when we're talking about nutrients, we're going to break it down into 6 essential nutrients, right? We are going to have our macronutrients and our micronutrients and water, right? So we've got macronutrients. I'm trying to build this as we go here. Your macronutrients are going to be nutrients that you need lots of, right? Right, so macronutrients we need a whole bunch of. These are going to be your fats. These are going to be your carbs. And these are everybody's favorite. That's your proteins, right? So carbs, fats, and proteins, we need a whole lot of those each day. And then we've got our micronutrients, which we need a little bit of, usually in the form of like milligrams, but those are our micronutrients, right? We don't need quite as many of those. That is vitamins, and that is going to be minerals, right? And then lastly, we've got water. Okay, so water, obviously the most vital of all of our nutrients, very important for us to be able to do everything we need to do. So essential nutrients, you'll hear that term, right? We can see that right here, essential nutrients. So these are our 6 essential nutrients. Now, remember, I think I said this the other day when we were talking about biology in general, guys, anytime you hear the word essential, it means that it is essential, that it is part of your diet. It is essential that you consume it in your diet, right? So nutrients that must be obtained for the diet for proper functioning, right? So macronutrients, you have to get them, right? These are nutrients required in large amounts. That's your carbs, that's your proteins, that's your fats. Micronutrients, you need them, but you need them in very small amounts, usually in the form of like milligrams or micrograms. Those are your vitamins and minerals, right? Certain minerals like calcium, for instance, they make up our skeletal system. We definitely need that in our diet, right? And in water, the most essential, that allows metabolism to basically happen. So those are all your essential nutrients. They have to be part of your diet. Otherwise, you won't be able to function properly. So macros in large, micros in small. So let's go ahead and break down like what each of these things are individually, right? So carbohydrates, right? I'm actually gonna make this whole thing just a little bit better. Put this over here and drag it kind of this. Okay, so if we're looking at our micronutrients, let's go ahead and break down carbohydrates here, right? When we look at like what a carbohydrate is, it's a compound of many different elements coming together, particularly carbon, hydrogen, and oxygen molecules, right? So if we look at like glucose, right? Here's a molecule of glucose, right? You can see they all kind of look like this. A whole bunch of carbon atoms, right? So carbon, a little bit of oxygen, and a little bit of hydrogen, right? So that's why they're called carbohydrates, right? Is because the carbon is going to be stripped from this, and we're going to use the oxygen and the hydrogen for energy. That's why carbohydrates are our favorite source of energy inside the body, right? So they're complex chains of like sugar molecules, right? We're going to convert those sugar molecules. This is an individual sugar molecule right here. This is one sugar molecule. Now, obviously, we can like link that together with other ones, right? We can link that glucose with like another glucose molecule. And what we end up with is what's called a disaccharide. I spell wrong. 2 C's, not 2 R's. And a disaccharide, like I said, double sugar molecule, right? So that's two, well, actually, sorry. Here's 2 glucoses together, right? When we put 2 glucoses together, we call that maltose. You've had maltose before. It's in milk, actually. So there's a little bit of maltose, right? So that's a glucose molecule attached to another glucose molecule. Now, there are other singular sugar molecules as well. For instance, fructose, which is found in fruit, that is especially sweet. It's actually sweeter tasting than glucose is. And it's just glucose in another form. It's just shaped a little bit differently. But like same ingredients, still carbohydrates, still carbon, still hydrogen, still oxygen, right? Now, if you take glucose and you add it to fructose, you end up with sucrose. That's table sugar. That's the stuff that we put in our coffee and tea and donuts, and we put it on all like baked goods and stuff. That's regular old sugar that you would put in like a batch of cookies, right? And then there's lactose, which is going to be glucose plus another single sugar molecule called galactose. So galactose, which is this little green one right here, again, looks really similar to glucose, right? But is in just an ever so slightly different shape, right? See how, like, literally, guys, if you look at the difference between glucose, this yellow one, and galactose, this little green one. Like, literally the only difference is this little oxygen molecule, instead of being down here, it's up here. That's it. That's the only like chemical difference. For the most part, it is identical. But because it's just in a slightly different shape, it tastes a little bit different, acts a little bit different. So that would be a single sugar molecule called galactose. If you attach that to glucose, it tastes very sweet, and that's where you get lactose. So now you have two sugars found in milk, lactose and maltose, which are just galactose and glucose plus glucose. A lot of oses when we're talking about sugars. There's other sugars out there too, like ribose, for instance, which is actually found in your DNA. And it looks really weird. There's ribose, right? Also a sugar. So that is sort of how our carbohydrates work. They're these big complex chains of sugar molecules depending on what their shape is in, right? So carbon, hydrogen, and oxygen. And there's single sugar molecules, but then if we link them together, we have double sugar molecules. Double sugar molecules are called disaccharides, di for double. Single sugar molecules would be mono for one saccharide. So monosaccharides and disaccharides. We also have our polysaccharides, right? Polysaccharides are big complex chains of lots and lots and lots and lots of sugar molecules, right? So for instance, we've got amylose, right? Amylose, let's see here, foods high in amylose. Yeah, rice, quinoa, beans, potatoes, right? A whole bunch of amylose is going to be found in those examples. Even bananas, right, are going to have a lot of amylose in them. Bananas are going to be a fruit, so there's going to be a whole bunch of like fructose in there, right? That's the fruit sugar. But there's also going to be, it's a low complex, right? That's amylose. And so amylose, each of these individual glucose molecules are all coming together in this shape. So that's amylose. But then there's also like amylopectin, right? Amylopectin, which you might be a little bit more familiar with. You're going to find that usually in like grains, like breads and things like that, right? Also found in like potatoes and stuff, like other starches that we're kind of familiar with. So what we're going to do is we're going to call, and by the way, these are not the only two starches out there. There's tons of categories of starches. They all act a little bit different than one another, but you can see this is in this shape, right? It's just a slightly different shape. That's all it is. It's just a big long chain of glucose molecules linked together. Depending on what shape you're making with it, that's going to determine what type of starch it is. So like you've seen these starches kind of get away from your food before. If you've ever made like rice, when you're boiling rice, you get that kind of sometimes like that little bit of scum, like the bubbles get like little, it's got like weird scum at the top. Yeah, you're actually seeing some of those starches leak out. Same thing in like potatoes. You boil potatoes, same thing happens. Even like you pour like pasta into water, you see it start to look a little milky. Those are little like sugar molecules leaking out, and then they start like linking together, in bits and pieces and stuff. But that's what starches are. I don't know if anybody in here is like and knows anything about cooking. I'm not a very good cook, but I do like chemistry. And I know one thing. When you are draining your pasta, if you're making spaghetti or whatever type of pasta you're making, it doesn't matter what type of pasta it is. When you're making it and you're draining it, you actually want to keep just okay, Lexia, you're my resident chef. You do want to keep a little bit of your pasta water, and you want to actually pour it back into your pasta when you're done. If you leave a little bit, it will actually concentrate the starches. Anybody in here who's ever made like buttered noodles, which is like the simplest pasta dish ever, right? It's like noodles, butter. Add a little bit of that pasta water, like just a little bit of it back into, and it will actually help it emulsify a little bit better. It'll be a little creamier. You would think that adding water would make something less creamy and it would water it down. But remember, this is very starchy water because there's a little bit of sugar molecules that got leaked out that are kind of hanging out in there. And so that is different than just straight up water. So there's your weird cooking fact of the day from the guy who doesn't know how to cook very well. Now, there's also our form, right? You guys recognize glycogen here. It's a complex carb, just like starches are. In fact, glycogen technically falls under the category of a starch because, again, it's a whole bunch of sugar molecules all linked together. But notice this. See how all of these are kind of like, there's like big gaps and kind of chaotic in terms of their shapes and stuff. If something was shaped like that, it wouldn't be really all that difficult for our digestive enzymes, let's say like your saliva even, to break this down. In fact, your saliva would take something that looks like this. Let's see, I'm going to zoom in here. Let's say you ate, let's say you eat a little bit of something with amylose in it. Let's say it's rice, right? Well, your saliva, before it gets to the rest of your digestive tract, is actually pretty good at taking 2 sugar molecules at a time and breaking them off. It can actually break down that carbohydrate into some disaccharides. Now, that's about as good as it gets for your saliva. When it comes to digestion, your spit really can only get it broken down into 2s. It doesn't get it any simpler than that. That's what you need the rest of your digestive system for, to kind of finally break off, the individual sugar molecules, right? The rest of your digestive system is going to kind of finish this off thanks to like your pancreas and things like that. But your saliva can actually break this down. That's why if you chew a food for a really long time, I used to do this as an experiment in class. If you guys go get a slice of bread today, put it in your mouth and just chew it, and don't swallow it, just chew it. I know it's going to get real nasty, but it will actually start to taste a little sweet. You will notice that it tastes sweeter after eating it for a while than it did originally. And that's because you are actually releasing little double sugar molecules thanks to the enzymes in your spit. So it's going to break it down like that, right? Now, you can see this is pretty complicated. And it would take some time to break down. Same thing would be true of amylopectin. It'd be really complicated. It takes time to break down. But here's the thing. There is a type of carbohydrate that just is so tightly weaved together, it is really difficult for our body to break down. And that is what we call cellulose. Cellulose is much more commonly referred to as fiber. In fact, it should say, it just says cellulose here. So cellulose is fiber. This is the parts of carbohydrates that we can't break down. This is a pretty good picture of what cellulose looks like. Look at how organized it is. But honestly, when you see a lot of people draw it, it'll actually look a little bit more like this, where like it's really tightly packed and really stacked together super efficiently. So when our digestive system is using chemicals like enzymes to try to break this down, it just doesn't work very well, right? We're just not able to kind of get between these things and cleave off, and break apart those sugars. They're so tightly packed that it doesn't work very well, right? It's all stuck together. So cellulose is what we refer to as fiber in our diet, and it's the part of carbohydrates that we don't digest. Has anybody in here ever done a keto diet? Anybody ever been on keto? Nobody. What the heck? What is this? Stop it. No, okay. So if you go on a keto diet, they'll say it's a very low carb diet. Let's look at keto macro pie chart. Take a look at what a keto diet looks like. It is 75% fat, 20% protein, and 5% carbs. So for me, if I eat a 2,700 calorie diet, right, I'm allowed 5% carbs. So 2,700 times 0.05, that's 135 calories from carbs per day, not 135 grams. If I divide that by 4, there's 4 calories in every carbohydrate. That gives me, I'm allowed, if I were on a keto diet, I'd be allowed 34 grams of carbohydrates per day. Now, let's take a look at 1 cup brown rice nutrition. 1 cup of brown rice has 53 grams of carbs in it. Oh, that's white rice. Whatever. I am not, if I were on keto, we would not be allowed to have a cup of rice a day. It would be too many carbs. So the point I'm making with that isn't whether or not keto is good. But here's the thing. Here's how keto people sometimes get away with it. Brown rice is going to have more fiber in it. The problem with white rice, the reason like rice is white, is because like we process the heck out of it. It goes through like a big machine that cleans it like really crazy, breaks it all up, which is kind of nice because it, you know, decreases the cooking time, starts processing it, makes it a lot simpler. It's way easier to cook, cooks way, you know, white rice cooks way faster, right? And has actually less calories. You look overall, like 242 calories versus 248, right? But here's the thing. If you look at the carbohydrate content, the carbohydrate content is 53 grams and 52 grams. So it's pretty much the same. Protein is a little bit lower in the white rice, a little bit higher in the brown rice. But if you look at the, oh, I picked one that didn't have fiber listed. You internet. There we go. If you look at the brown rice here, it's got 4 grams of fiber in it, and the white rice has 0. So what that means is that there is more cellulose present in the brown rice, which means some of the carbohydrates that I consume are not going to be absorbed by my gut. It's not going to be absorbed by my digestive system because it's so complex. It's got all of that cellulose in it that it can't break down, which means it never enters my bloodstream, which means if I have any calories from that, or if I have any carbohydrates from that, it doesn't really affect me, which is why keto people actually still can have like vegetables in their diet because they actually have to subtract the grams of carbohydrates they're getting from the vegetables. So let's look at like 1 cup of broccoli and say we were on like a keto diet. Okay, I can't pick broccoli because Google's not giving me its little calculator thing. Let's go back to asparagus. Yeah, we'll use asparagus as an example. So let's say you have 2 cups of, or a cup of asparagus with your meal. If you look at it and you're on a keto diet, that's 5 grams, which means you just went through 1/6 of how many carbohydrates you allow per day. But notice how it's got 3 grams of fiber in it out of that 5. That means that you have 2 what are called net carbs, which means you're actually only getting 2 grams of carbs from that asparagus. Does that make sense? Like 3 grams of it do not enter your bloodstream because it's fiber. That's how complicated fiber is. We don't absorb it. So the calories from it, the grams of carbs from it don't really count. Now, again, that's not me advocating for keto, but that is how it works. And it's a really good way to understand what fiber is. It is impossible for us to absorb because cellulose is too complicated. Now we've also got proteins, right? So there's our carbohydrates, right? And we'll put that down here. Carbs are going to be monosaccharides, disaccharides, and polysaccharides. I need that to be a smaller font. Oh my God. Let's go with. So those are our carbohydrate types, right? So next one we're going to look at is protein. So protein is really similar to carbohydrates chemically, except that it's got this extra bit of nitrogen. And so that nitrogen can form itself in the way that we had carbohydrates, right? We had 3 types of carbohydrates, and we had like 3 types of monosaccharides making up all those carbohydrates. We had glucose, which is the most common. We had galactose, which is found in sugar, and then we had fructose. Not fructose. I'm forgetting my freaking things. Galactose. Yeah, fructose. Okay, I'm crazy. Fructose found in fruit. Glucose found in pretty much all starches. and galactose found in milk. Those are the three little like single sugar molecules that make everything up, and they form themselves in different shapes, right? Proteins have 20 different individual types. There are 20 amino acids out there, and that's what a protein is. It's this big complex chain of amino acids, right? So when you take an amino acid, we take an amino acid and you put it together in one shape, it might look like that, and then you put it in another shape, it might look like that, right? And so there's different examples of proteins out there. Here's what they look like on a chemical level. That's freaking complicated looking. Right. Which is, by the way, it's my favorite thing to draw. It's the one thing that I know how to draw well. I always tell people, like, I'm not an artist. John, I'm going to leave that to you. But I will tell you this. The one thing I can draw the heck out of a protein. You ready?
Yep.
There we go. There's my protein. We always just draw them as squiggles. Like, there they are in all their various really weird, unique, super cool shapes that are out there, right? So there's a whole bunch of different shapes of proteins, right? And that's why there's so many different examples of protein out there, right? Like, obviously fish scales are very different than our skin, which are very different from like a chicken's breast, which is very different from like our pec muscle, but like they're technically similar, like look at how many proteins are out there. And then there's proteins that are going to be found in fruits and vegetables and nuts and seeds and plants. Like we talked about brown rice a minute ago. It's got some protein in it, not a lot, but it's got some, And so there's a whole bunch of different examples of proteins out there. Your receptors on your cells that, like your muscle spindles, your Golgi tendon organs, your taste buds, your nose, sense, God, what are those things called? Smelloreceptors. That's definitely not what they're called. We get out of muscles and hormones are made out of proteins. Like there's so many different, hemoglobin in your blood, that's a protein, right? So how the heck do we get so many proteins? Well, we take those chains and we link them together, but we link them together in different orders, right? So when you look at an amino acid, it's got 20 ingredients, right? So where's that example? I'll just use this. There it is. Here's an amino acid sequence, right? So this is what we pulled up a couple days ago, right? This is literally the difference between proteins, right? So, imagine if you're looking at this, right? Maybe this over here, this sequence is collagen, right? So that's that. Man, I spelled that totally wrong. Oh my God, that's way wrong. Collagen. Good Lord. I want to remind everyone that I am a biology teacher and physiology teacher, not an English teacher. Over here, you've got like actin. This one's maybe myosin. So again, when we talk about our digestive system, it's just a de-assembly line. And then inside of your body, your DNA, that's the assembly line. So DNA tells your body what order to put these amino acids in. So there are 20 of them. If we look at an amino acid, it's going to look like this. Okay, we often draw them like this here. Okay, where it's a little bit of carbon, a little bit of hydrogen, a little bit of oxygen, but then there's a little bit of nitrogen here giving it a skeleton. And then there's this big R over here. So that's not on the periodic table. So what the heck is the R? Well, we call that the R group or the side chain. And this little like box here is basically a fill in the blank. And it's going to have 20 different shapes in it. In fact, if we look at like amino acids, and you look at them, they're all shaped just a little bit differently because all of their R groups, all of their side chains just look different from one another, right? So you can see here, these are really similar, right? Arginine, histidine, and lysine, right? And you can see they're just in slightly different shapes. There's aspartic acid and glutamic acid, right? Cysteine, glycine, proline, all of these, they just look a little bit different from one another. But it's a little bit easier to visualize them. It's a little bit easier to picture them when you picture just a chain with like a little circle in a different color, kind of representing each amino acid. Okay, so I always like to kind of think of them like this, just a little bit. And if you put them in a different order, it's a different protein. So that's what proteins are. They're just these big complex chains of amino acids in different orders. And that's ensuring like what they are, you know. Imagine the world's greatest chef who can make literally any dish on the planet with just 20 ingredients. Depending on what order and what levels, you know, a quarter cup versus a full cup, you know, depending on how he puts those 20 ingredients together, he can make any meal on the planet. That's pretty cool. You know, like that's how your body is, right? That's how your body assembles all these different proteins. So we go back here when we're looking at proteins, you know, like I said, they are complex chains of amino acids. What is an amino acid? It's a compound made of carbon, just like carbohydrates, hydrogen, just like carbohydrates, oxygen, just like carbohydrates, but it's got a little nitrogen in there. It's got a little skeleton that carbohydrates don't have, and that's what makes them unique. Now, when it comes to those amino acids, there's 20 of them, like I said, and we're going to break those down into essential and non-essential amino acids. Non-essential amino acids are amino acids that your body can actually make. Whereas essential amino acids, your body cannot make those. So if we look at this list again, this is the same list I pulled up a second ago, although that's the lower quality version of that picture. Blah. Okay. So here's that picture I just pulled up a second ago, right? So you look at like arginine and you look at histidine, they're pretty similar. They look really darn similar, right? There's a little bit of extra hydrogen and nitrogen over here. And then like this, you know, kind of forms into a link. Well, guess what? If I were to break that off and just slap it over here, it would look really similar, right? If I just broke this tail off and put it over here, I'd have enough lines, I'd have enough like chemical bonds to put it all together. The first top of it's identical, right? So once I get this kink here, I just break that off and break that off, bring it over here, right? I wish I could do this in paint. That'd be so cool, like it does in real time, but I definitely cannot. I take all this stuff, put it over, and like finish off the chain. Now I broke down arginine and I ended up with histidine. Awesome. That's a non-essential amino acid, right? It was something that I was able to break up and resynthesize using the ingredients that I had from other amino acids, right? Because I need all 20 to make a protein. I cannot make any proteins. You cannot make any proteins in your body without all 20 ingredients present. The chef will not start working if he doesn't have all ingredients there. Some of them he can make himself, right? So like he needs garlic, he needs salt, and one of his other ingredients is garlic salt. If he didn't get any garlic salt in his delivery, he's like, all right, that's fine. He can break down garlic, he can break down salt, put them together, boom, he's got garlic salt. Now he can start cooking. So he needs all of those ingredients present, right? Same thing with you, right? You need to have all those ingredients. So non-essential amino acids, you're fine. Essential amino acids, you have to get them in your diet, right? Now, how the heck do we get those? Well, there's going to be the difference between what we talked about a couple of days ago when we said there are complete proteins and there are incomplete proteins. Complete proteins have all the essential amino acids. Incomplete proteins don't. So if we kind of draw a line here, right, we break this down, you've got, oop, those are fats. I'll move this in a second. Complete versus incomplete, right? So those are our different types of proteins, right? Complete versus incomplete, right? So a complete protein, it's got all the ingredients you need. Now, I'm going to be a little biased here, and I am not saying you have to be an omnivore. If you want to lead like a vegan lifestyle, you can absolutely get all your amino acids in, 100%, guys. You do not need to eat meat to get all your amino acids. However, I will say this, animal products, meat, eggs, dairy, right? will always guaranteed give you a complete amino acid profile. Because when you think about it, we need all 20 ingredients to make new hemoglobin. We need all 20 ingredients to make new DNA. We need all 20 ingredients to make new muscle. We can't do it without all 20 ingredients. That rule is true for an animal as well. So if an animal's body assembled protein, amino acids together to make a protein, you know that it's got all 20 ingredients. Plants can get away with it by having very little, in such little amounts that we might not even necessarily get amino acids from it when we're breaking it down. That's why plants are often non-essential. Now, again, to be clear, you can just combine two non-essential incomplete proteins. You can just combine two incomplete proteins together and you've got a complete protein. So like beans plus rice is the classic example. Rice plus a grain, beans plus a grain, nuts plus a grain or a bean or a seed, right? Put them all together, you've got a full profile. You don't have to worry about it. But yes, it is, in my opinion, because I'm biased, I think it's easier to ensure that you're getting a full amino acid profile by being a carnivore or an omnivore, I should say. We need vegetables too. So that is the protein breakdown. And lastly, we've got fats. Fats are actually exactly the same compounds, the same ingredients found in carbohydrates and proteins. But there are a couple different examples here. Oh, this is just a perfect chart. This is great. Give me this picture. So you are going to have three main classifications of fats. You're going to have unsaturated fats, saturated fats, and then there's this one over here which shouldn't exist, and that's called trans fats. We'll talk about that in just a second. But when we're looking at fats, they look chemically different. When you look at how fats look chemistry-wise, there we go. They're going to look like this. So this is what's called a saturated fat. Okay, here's a couple examples of saturated fat. They're here in the middle, right? Saturated fats are solid at room temperature. They are fats that form kind of a straight line. So because they form kind of a straight line, they're able to stack pretty efficiently on top of one another. And so that's why they're actually able to be solid at room temperature. You know, that's the difference if you look at the three states of matter, not to get all physics or chemistry on you guys, but you look at the three states of matter, the difference between a solid, a liquid, and a gas, right? Gases have big gaps in them. They're very complicated looking. Liquids they got some gaps in them. They're relatively complicated looking. Solids are molecules that are stacked together really efficiently. Well, you got a bunch of straight lines, stacks together really efficiently, it makes a solid. Oh, wait, that's the same thing that was true of cellulose a minute ago, right? Remember cellulose? It was stacked together very efficiently. That's why we couldn't break it down. Kind of true of fats as well, guys. Really similar. So saturated fats are the stuff that often clog up our arteries. Remember when he was talking about like, don't eat the steak in the video, right? Yeah, saturated fat is solid at room temperature. So when you look at like a stick of butter, cheese, right? Meats, you see like if you look at the steak here, right? It's got the marbling on it, right? Even fish, which is actually very high in unsaturated fats, has saturated fat within it, right? See the little white bits in between. It has some saturated fat. Avocado has some saturated fat, even though it's very oily, right? So saturated fat forms these straight lines, which means it can stack very efficiently and become a solid when it's at room temperature. You heat it up, it can start to liquefy, right? Like coconut oil. Like a coconut oil in this picture? No, I don't. Give me coconut oil, right? Right? It's a solid at room temperature, but if you heat it up, it starts to form like a liquid, right? So that's saturated. Now, unsaturated fats, they are liquid at room temperature, right? So when we look at like the really oily stuff on fish, the oily texture that you sometimes feel when you like crack a nut in half, right? All of that liquid stuff, right? It's kind of shiny, right? That's unsaturated fat. And the reason it's liquid is because it forms these kinks in it. So because it's kinked, it can't stack very efficiently. There's more space between the molecules. It makes it a liquid. You break it up even further, it'll become a gas eventually. You superheat, it'll become a gas. But that's unsaturated fats. Okay, so now we're looking at it. We've got 3 types of fats, right? We are going to have unsaturated. And actually, we have 2 versions of unsaturated. In this picture, you can see 1 kink. Okay, that 1 kink would make that what's called a monounsaturated fat. And that's what you'll sometimes see when you look at like nutrition facts. Say almonds. We'll pull up almonds, right? Oh, come on, Google. Man, Google usually pulls up its freaking nutrition labels, and I love it. It's so helpful. Because it's got all the fats present instead of just 2 of them. There we go. So here's almonds. If you take a look, you'll notice it's got 4 types of fat listed: saturated, trans, and then it's got polyunsaturated and monounsaturated. We go back to our example over here, right? When it comes to unsaturated, there's 2 categories. There are polyunsaturated and monounsaturated. Monounsaturated, that's usually like nut-based. Polyunsaturated tends to be like fish-based and seeds and things like that. So slight differences between those 2. A lot of vegetables will also be polyunsaturated. So what's the difference between monounsaturated and polyunsaturated? Well, you can see here in this picture, there's 1 kink. That's 1 mono. That's a monounsaturated fat. If it had 2 or more kinks in it, that would be a polyunsaturated fat. They're very similar. And for the most part, we can just think of them as unsaturated. So that's the good type of fats. Okay. So we've got monounsaturated, polyunsaturated. Then we've got saturated fat. Then we got trans fat. So trans fat, I'm trying to get enough space to put this here. Make a little bit of space for myself here. Okay. Saturated fat, also not very good for us. It's that solid at room temperature. You're going to find it in 2 sources. You'll find it sometimes in vegetables, but you'll often find it in like animal fats. When I was a kid, man, I loved hot dogs. Loved hot dogs as a kid. I would eat hot dogs cold, right out of the fridge. Loved them. Anybody who's ever done that, you might remember, it's kind of weird. You get this kind of weird texture, this like oily, greasy texture inside your mouth when you're done eating it. If you ever eat a raw hot dog, that is all the trans fat being solid because it's sitting in the refrigerator kind of cold. It's like if you had coconut oil in your fridge for some reason, you scooped it out and ate it. It would taste greasy and weird, you know. That's what that is, solid at room temperature, right? And then we got vegetable fats as well, you know, found in like coconuts and certain things. You'll find saturated fats all over the place in animal sources as well. Now, saturated fat, you can see this chart is saying like these are good and these are bad. Saturated fat is not as bad for us as we once thought. A lot, you know, it still has like a lot of benefits to it and can even help us like lower our cholesterols in some ways. Saturated fat has some good qualities, but the problem is we eat way too much of it. It just is a large part of our diet, and our body's like, I can't keep up with this, so it starts clogging up our arteries. That's why when you're eating saturated fat, we want to keep your fat intake to, let's say you're keeping your fat intake to maybe 20%, right? You only want 10% to be from saturated sources. So if you're eating 2,700 calories a day, that's the example I was using earlier, times 0.1, that's 270 calories divided by 9. For somebody like me, I really should only be getting about 30 grams of saturated fat per day. If I keep it around that or lower, I'm going to be in a really good spot, and they're not going to hurt me that much. So it's only about 10% of your diet that we want to be coming from saturated sources. Now, there is also what is known as trans fat. Trans fat does not exist in nature. When it comes to diets, you guys are going to learn this pretty quickly. I don't like telling people what not to eat. I really don't. I like to tell people what to eat because I think that's much more constructive and helpful. Here's the exception to that rule. Do not eat trans fats. As much as you can, try to avoid them. Now, what a trans fat is it's where we take an unsaturated good fat and we superheat it. We turn it up to super, super, super high temperatures, like deep frying. And then we throw food into that deep fryer. It makes a very delicious, wonderful crust on our food. It is not good for us. Trans fats are the devil's fats. So I'm just gonna go like this real quick. We're gonna give this some devil horns. Stay away from this stuff. It's real bad. Trans fats, honestly, the reason they're so bad for us is because they act like an unsaturated fat, but then they clog our arteries the way saturated fats do. Your body thinks that it's getting very unhealthy food, and then it utilizes it. It has been shown to destroy your good fats. It's been shown to literally go in there and destroy our good fats. So, saturated fat is kind of bad for us because like it does some bad stuff. It acts badly in its own right. Trans fats go into our body, and not only does it do the same stuff that the saturated fat does and clog our arteries, it also destroys our good fats. So it's not just like bad on its own, it's also going in and corrupting the good stuff. That's not good. So try to avoid fried foods as much as you can. I know they're delicious. We all love donuts. They're not good for us. All right. So those are your macronutrients in a nutshell. Now, the next one we've got, and again, by the way, same ingredients. That's why they can be used for energy. Next one we got vitamins and minerals. So vitamins, what's cool about vitamins, they look like proteins. They're really similar to proteins, actually. They got carbon, hydrogen, oxygen, just like our ingredients that gave us energy did, but they also have nitrogen, just like protein does. However, the levels are so low that we can't use them for energy. You're not getting any calories from vitamins. For the record, there are calories in vitamins. They're just so small that we don't really measure them. They exist. They're just tiny. And they allow certain physiologic properties to happen. So there's going to be two categories of vitamins, just like the other one. So we're going to have two major categories here. We are going to have fat soluble. Those are vitamins A, D, E, and K. And we are going to have water soluble. That's your vitamin C and your B complex. The reason we call it the B complex is complex. There's a bunch of them. Okay, so those are your two major categories there. I need to make space. Those are your two major categories of vitamins, right? So fat soluble vitamins, they're called fat soluble because they dissolve in fat and they are carried and transported by fat. Water soluble vitamins dissolve in water and they are carried and transported by water. So, you can become vitamin deficient actually by not getting enough water in your diet. You can become vitamin deficient by not having enough fat in your diet. This is why low-fat diets, which were so popular back in the day, are also not very good for us, right? Super low-fat diets are also not considered healthy because you might become vitamin deficient. A lot of people really love smoothies, right? Here's the thing. I like smoothies, right? Let's look at simple smoothie recipe. It's like a really simple smoothie recipe, right? Look at that. How easy is that? This is great. Strawberries, banana, a little bit of peanut butter and milk, right? That's kind of weird, right? You think of smoothies, you think of fruit. What about over here? Pineapple, banana, coconut milk, and coconut oil. Okay. Strawberries, peaches, yogurt, and then coconut water. Spinach, mango, banana, and lemon. Okay, so this one right here, the spinach, the mango, the banana, the lemon, really packed full of nutrients. I like it. I really do. Here's my problem with it though. If you look at this, strawberries, banana, peanut butter, and milk, that is giving you a little bit of fat and then lots of vitamins in it. So that fat is going to actually help you absorb all of the vitamins A, D, E, and K in that smoothie. The pineapple, right? It's got coconut milk, which has fat in it when you bring it in at the same time, right? So I like this spinach, mango, banana, lemon one. It's got a ton of nutrients in it. What I don't like about it is that it's missing fat. So people who do smoothies for breakfast often feel really hungry later on because maybe they didn't have any fat in there, or they might not actually be absorbing all these nutrients that they're bringing in. This is a super healthy food that they might not actually absorb fully. So you know what I would do to fix that? I keep it really simple. I'd say, hey, add to that, and this is going to amp up your calories a little bit, which is kind of a bummer, I know, but add a tablespoon of olive oil to that smoothie. You won't even taste it. It'll keep it tasting the same, but you'll absorb those vitamins a lot better. And then there's plenty of water present in all of this, which is, going to make it easy. Super fruit, cherries, kiwi, almond milk, that might have some fat in it, but probably not. And chia seeds, there we go. Chia seeds are a good source of fat. That's a really good one, actually. These are great. Big fan. Love it. So I like smoothies. I really do. But I do think that they get misused sometimes. So fat soluble and water soluble vitamins, they're going to do different really cool physiologic things inside of our bodies. Oftentimes they interact with minerals to do some really cool stuff. So for instance, vitamin D helps us use calcium more effectively. So speaking of minerals, what the heck are those? Well, minerals, there's a bunch of them. Actually, sorry. So we got a bunch of different minerals that we're going to consume. Whole bunch of them. Calcium, iron, potassium, zinc, magnesium. Those are probably the most important. Those are the ones that most people are familiar with, but you're going to be getting them from all these various sources in your diet, right? We need to make sure that we are getting a good source of all of these minerals. Those are our vitamins there and some minerals. That's not what I wanted, actually. Just minerals. Yeah, there we go. Look at all these things, right? Magnesium, calcium, potassium, iron, fluorine. That's a weird one, right? That's for your teeth. Selenium, that's in Head and Shoulders, that helps you with dandruff. Copper, magnesium, zinc. Zinc is so cool, guys. Zinc is like one of my favorite minerals. You guys want to see video of this. Oh, come on. I want to see like actually happening. Here we go. Okay, check us out. So here is your immune system in action. So you got a little cell here, right? And it's going to shimmy its way up to a little virus, right? So these are actually two different. Okay, so what's going to happen? It's going to kind of shimmy its way up, right? You can actually see here's a little virus, and here's like a little cell, right? And what it's going to do is it's going to puncture that virus and go and basically suck all the liquid out of it and dehydrate it and kill that virus. Pretty cool. Hold on. Wait for it. And the way it does that, the way it actually punctures, it actually uses zinc in order to do that. That's actually why, like cold medicine, if you ever look at the ingredients, it will often have zinc in it, right? So eventually it'll just kind of puncture that thing and dehydrate it. I'm going to skip forward a little bit because obviously this is very slow. Oh, dang it. So it's kind of hard to tell, but see how it like kind of shimmies up next to it. It's basically drinking out that virus. It's going to keep going, and it's going to keep kind of sucking that all out. That's it uses zinc to do that, which is so cool, right? So chromium's another one. Phosphorus is huge for ATP production, right? We get that from fats. So there's more, but there's a whole bunch of really cool minerals inside of our body. Now we are going to classify them in two different ways. We're going to classify them as major versus trace. Okay. And major versus trace, that doesn't mean that like all the major ones are really similar to each other. Every mineral is different. They're all completely different. It just means major. It means you need a lot of them every day, and trace means you need very little of them each day. So we don't need a lot of trace minerals. You need those usually in like micrograms, whereas like major minerals, you need like milligrams. So you need a little bit more of them. So that means that like major minerals, you need more than 100 milligrams per day. Trace minerals, you need less than 100 milligrams per day. So that's all we did. We just split it based on how much you need. Chemically, they are all different from one another. So it's not that like all the majors share a common trait. Like fat soluble, they all share the trait of like dissolving in fat. Water soluble all share the trait of that's not how minerals work. There's not a similarity there. It's just we need a lot, we call them major. We need a little, we call them trace. And then we got water. Water is hugely important. Right, so water helps us regulate body temperature. It also helps us lubricate our joints. So remember we talked about those pressure sensors yesterday when we were talking about like joint receptors, right? You experience like that pressure within the joints. Guess what? If you are dehydrated, your joints are going to hurt. Why do you think your joints are achy so bad when you have COVID or the flu or something like that, when you have a fever, right? This is part of the reason why it's so important. Like every doctor, what they tell you, stay hydrated, right? They mean it. It'll help. It'll lower your symptoms, right? Won't help you necessarily get faster or any better. That's just going to take time. But like, it will lower your symptoms, and it transports everything around our body. So super, super, super important. We need hydrolysis in order to literally do everything that we do, right? We cannot break down ATP, use ATP, make ATP. Can't do any of that without a little bit of water, right? So either through dehydrating stuff or hydrolyzing stuff. Hydrolysis will break stuff up. Dehydrating stuff will build stuff up. So we need to like suck water out of things to make tissues. We need to push water through things to break stuff down. And we are just constantly doing that in our metabolism. So that is why water has been shown to be such a huge part of your metabolism. Again, guys, you probably need about a gallon a day. Ladies, you probably need about 3/4 of a gallon per day. And if you want to drink a gallon per day, guess what? It's probably not going to hurt you. So that's huge. Now, one thing about macronutrients, which we said we need them in like large amounts, right? They are also what we call energy nutrients, meaning that they have the calories, right? So our macronutrients are giving us the calories, doing everything to allow us to like move around, right? That's how we produce ATP, right? So like a piece of bread, oh, there we go. Now Google's doing it, right? Piece of bread might have a 30-gram slice of bread, might have about 80 calories in it, about 79, about 80 calories, right? 80 calories. I don't know how much ATP that is. I wonder if we can even figure that out. How much? How much? Probably not going to work this way. Yeah, see, they're different units. 1 molecule of ATP will give you, oh, okay, 7.5 calories, really? Huh. Seems like a lot. So you might get like, that does not seem right. Oh, it's I'm sorry. So it's a regular lowercase calorie. That does make sense. So one ATP molecule will give you about 7.5 to 8 calories with a lowercase c. That means that it will give you about 8 out of 1,000 of 1 calorie that we're usually talking about. So you're creating a lot of ATP every day. You know, because you're eating, like, let's see, 2,700 times 1,000. That's 2,700,000 divided by 7.5. You're creating about 360,000 molecules of ATP every day out of a standard everyday diet. Cool, right? So that's a lot. So that's kind of how we're breaking it down. We need to be able to produce ATP, and we're going to be able to do that from like the energy trapped within foods. That is why we have our recommended amounts every day. So here are some terms that you guys are going to see. This is what kind of sucks, guys. What I'm about to say. This is the kind of thing that like makes a really good test question that honestly is not that helpful in the day-to-day world of helping people with nutrition. Memorizing these numbers isn't really going to be helpful. Memorizing like the recommended number of milligrams per day isn't really helpful. It's helpful with like water. It's helpful with calories, but these do need to exist for scientists to figure out like regular recommendations. And then we start to translate that information to like, how many vegetables should I eat per day? It's like, well, the answer is enough to give you these dietary reference numbers, the right number of milligrams of calcium, iron, vitamin C, you know, all that stuff. That's how many cups of vegetables you're eating per day. But how do we translate that into information for our clients without making it impossible to adhere to? We say 9 to 13 cups. It's an easy way to break it down, easier to understand. But you are probably going to get a question or two on your test about what we call DRIs. So here's our definitions. Dietary reference intakes, or DRIs, are how we are going to quantify your nutrient needs. Now, you guys might be familiar with one of them called the RDA. When I grew up, RDAs were everything when it came to food, right? Like these percentages, the percent daily value, which is based on a 2,000 calorie diet, those were the original RDAs for certain foods. But we just found that it wasn't quite accurate enough and helpful enough. So they started breaking it down a little bit more. So now we call the whole category, we call all of them put together, we call those your DRIs, the dietary reference intakes. It's what's recommended for healthy individuals, right? Or, you know, what's recommended to be a healthy individual. So the RDA is the recommended dietary allowance. It's the average intake to meet the needs of like 97.5% of people on the planet, right? Like when we say, hey, you need, let's see, RDA, right around 2,300 milligrams of salt per day. Okay, that's how, not salt, sorry, 2,300 milligrams of sodium per day. Okay, that's about how much the average person needs. We definitely get way more of that than that in our diet, but hey, that's how much you have to have, right? That's going to help you with your action potentials and, you know, moving your muscles and stuff. Okay, that's how much we needed for that. So cool. What about people who are special cases though? Or what about like, what's the bare minimum, right? Well, that's where the rest of our DRIs kind of came in, right? So we have what's called the estimated average requirement. This is the bare minimum needed to meet the needs of half of a population. So 50% of people, right? So the EAR for sodium, oh God, sodium's the salt's in the ear. Yeah, that's not what I want. What? Oh, it doesn't have a number. Oh, there we go. So the EAR, the bare minimum for about 50% of people, that's also not the right number. What am I looking at here? If 2,300 is the number, that's not right. Well, it's probably interesting. Trying to find the right numbers here. You know what? I'm just going to kind of make up a number. If the recommended average is 2,300, chances are the bare minimum is probably closer to like 1,000. That's the estimated average to meet the needs of 50% of people. Now, if everybody ate that much, 50% of people would not be so healthy, but at least it's enough to kind of help us understand. There's also the adequate intake level. Okay. This is the recommendations when there's not enough evidence to know what the RDA is. So they're recommended, if we don't know what to actually recommend, but we know that it's like something that we need just like a little bit of, that's what we use the adequate intake level for. It's the minimum amount needed by a population of people, right? So like, we don't know how much calcium is perfect for seniors, but we do know that they need some in order to fight off osteoporosis. So we might use like the adequate intake level for that. And then there's also the tolerable upper intake level, which is exactly the opposite. That's the highest before it starts causing effects. Because guess what, guys? We love vitamins. Too much of them can hurt you. Guys, in my call right now, too much iron can cause your blood to actually stop carrying oxygen effectively. Too much sodium can give us hypertension, obviously. Too much vitamin C can cause canker sores. Too much vitamin B can cause neurological problems. B12. Wait, B6? One of those. So we do have like upper levels that can actually become toxic, you know, if you are getting too many of like a certain vitamin or mineral. It's rare. I've never once had it happen to any of my clients because I'm always like, would you please get some freaking vitamins? You know, like, but it can happen. It definitely can. So those are our dietary reference intakes, right? Most common one that you guys are going to use is the RDA, but we needed to have other ones to get a little bit more specific just in case people started, you know, overdoing it and stuff. And that is the broad strokes of nutrition. Everything else we're going to talk about today is pretty simple, you know, in comparison. So for instance, you're going to see these two terms. They're going to come back in a couple of days, but we're going to see the difference between what we call enrichment and what we call fortification. Now, these are two things that the government started doing to certain foods that were common to most people in a way of adding vitamins and minerals to the diet because people weren't getting enough of them. So for instance, enrichment is the addition of vitamins and minerals to a refined product to increase their nutritional value. So if we look at like enriched foods, what that's going to be is like flour. You've probably seen flour before in the grocery store, and it'll say like enriched bleached flour, right? And what that means is like they took flour, they processed the crap out of it. That killed a bunch of nutrients. So what they did is they took those nutrients that would have been present in that flour and they added them back in. When you look at like cereal that has protein in it, right? When you make cereal, it loses a lot of its protein. There's just not a lot of protein found in grains. So what they did is they added some extra protein back in. And now you have extra high protein, right? Not because it's like magic cereal that already had some. It's because they just added a little bit to it. They enriched the amount that it already had. Now, there's also fortification. Fortification is adding vitamins and minerals to a food that didn't have those. You know, for instance, like orange juice has a lot of vitamin D in it, does not have very much calcium in it. But guess what? Now you got orange juice with calcium in it, right? Because most of the population needs more calcium in their diet. So it was fortified, right? And basically it means they're taking calcium powder and dumping it into their orange juice. So when you see something has been enriched, it's where they added what was already there and just raised the levels. And when you see something is fortified, they added something that didn't exist in it before. Honestly, every protein shake you guys have ever had has been enriched and fortified like crazy. Because if you eat just regular old, that is 100% what they did with Wonder Bread. Yes, let's take a look at Wonder Bread. Whoop. 100%, yeah. You'll see it. It'll say it on there. calcium fortified enriched bread. there is some rocks in this bread. There's a little bit of calcium, which would not normally be found in bread, in grains, right? Calcium is going to be found in other sources. But we added it to this. Great. And we've got a lot of it. When it comes to nutrition guidelines for our clients, these recommendations can be implemented into an exercise plan. However, guys, key sentence right here. One thing I need you guys to be aware of, we are not allowed to prescribe food. Food in this country, in the US, is considered medicine. So if you were to tell someone, hey, Simon, I need you to eat 9 cups of vegetables per day. Here's the thing, it's actually pretty good advice. It's not, it's honestly, it's a really good piece of advice to give you, right? But I just told you what to eat. I told you specifically that I want you to eat this thing. I prescribed it. That is stepping over the line. That's not what we're allowed to do. What I can say is, hey, Simon, it would be a really good idea for you to get 9 cups of vegetables in per day. So that difference, that distinction right there is key, guys. We are not allowed to prescribe food, but we are allowed to be nutrition experts, and we can convey information to our clients. You know the phrase, it usually describes like a stubborn person. They say, oh, you can lead a horse to water, but you can't make them drink. That's to describe somebody who's stubborn, who's like, you gave them the best advice, but they didn't listen to you, right? I want you guys to think of that phrase whenever you're thinking about nutrition. You can lead the horse to water, but don't push their head into the water. Don't prescribe food. We can't make them drink. But we can say, we can clear the path, we can pave it, we can light it with pretty candles and lights. You know, we can put a giant sign that says, go this way. You know, we can do everything in our power to get them there. Just don't make them do it. So that's the distinction that we're going to be practicing over the next couple of weeks. Here are some of the things that we can do that are generally good. This is generally good piece of advice to follow. Try to balance your calories, right? Excessive calories coming in is going to result in weight gain. Excessive calories going out is going to result in weight loss. So tell me what your goal is. Oh, you want to lose weight? Great. You should probably create a calorie deficit. Oh, you want to gain weight? Great. You should probably create a calorie surplus. General advice. Didn't tell them exactly what to do. I could even calculate it for them. I'd be like, all right, well, based on your BMR, you know what, Joseph, you need about 2,700 calories per day. I can even do that for them. I can say that. But what I didn't say was, Joseph, I want you to eat 2,700 calories per day. I know the distinction's kind of weird. And honestly, guys, if you step over the line, I'm sure I've stepped over the line 5,000 times in my career. But the day that I do it and someone gets sick from food that I prescribed and then they try to sue me, I'm liable. That's the difference. And for the record, I've been in this industry for years. I've seen trainers step over the line constantly. Never once heard of somebody actually getting sued. But technically it could happen. So why take the risk? Do you have a question, Simon?
Yeah, so how does that work as a nutritionist? Like, do we make meal plans for our
Sort of.
people? Whatever?
We can make an example meal plan and say, this would work really well for you.
Oh,
We cannot say, eat this. That's the distinction. It's a weird distinction. It's small. It's a little tiny thin line, but it is an important one. For the record, nutritionists cannot do that. There's not a nutritionist in the country that's allowed to give someone a diet and say, eat this. Dietitians can, because dietitians are medical practitioners. They're like doctors. Doctors can prescribe stuff. We can't. That's the distinction. So any nutritionist out there cannot prescribe food, but dietitians can. Just like a dietitian cannot say, hey, I want you to do 3 sets of 20 push-ups. That would be super inappropriate for them unless they're certified as a trainer. But if a dietitian said, hey, you should probably increase your physical activity, maybe go for a walk each day, they can totally do that. But they cannot say, I want you to walk 3 miles. Does that make sense?
Yeah. All right.
Cool. Same thing. So general advice, right? Try to limit your sodium, guys. We get a lot of sodium. We pack it into everything, right? I was drinking this thing that I shouldn't drink, you know, these ices. I love these things and they're so bad for you. Oh, it doesn't have sodium listed. Thought it would. I kept this up here so I could pull it up in class. It has artificial sweeteners in it. That's why I'm not a big fan. I will be talking more about those later on. But try to limit your sodium. Try to limit your saturated fats. Try to make sure that you're controlling your cholesterols and solid fats. Again, saturated, right? Try to avoid the added sugars, guys. God, sugar is bad for us. It's just too simple. It enters our bloodstream instantly, and our body has to like play catch up to process it. Refined grains, alcohol. God, alcohol. There's no value in alcohol. Nutritionally, it has zero value. They used to say, oh, a glass of wine a night, it's good for you. No, that is bunk. That has been debunked. The reason they used to think a glass of wine was good is because they were noticing people who drank a glass of wine would live longer. Had nothing to do with the wine. It's like if you have a glass of wine at dinner every night, you're probably a pretty relaxed person who's enjoying life. That's the key to living long. Be de-stressed, but the alcohol, you can get that from playing video games, which is also not very good for you if you're very sedentary. You can get that from doing a puzzle. You can get that from painting. You can get that from playing with your dog or your cat, that will help you live longer, but we thought wine, really, there's no value in alcohol. Try to increase the intake of certain foods, vegetables, fruits, whole grains. Try to go low fat. Try to get plenty of try to get adequate protein. You don't need to go crazy on the protein. And then try to build healthy eating patterns. Get used to doing this regularly. One of the ways we've done this, and this is what I'm going to teach you later on, so it's not in your notes today. One of the best ways to ensure that you are eating a goodly amount of the right types of foods, this is what replaced the food pyramid, right? Look at the original food pyramid from the 90s that I used to use. Man, the old food pyramid was so bad. This is what mine used to look like this is what I was taught in school as a kid. Most of your diet should be whole grains, and then fruits and vegetables, a little bit of milk and cheese, a little bit of meats. And then up here, they had a space for baked goods. They're like, you can have donuts and ice cream and stuff. Just, limit it, which honestly is actually not that bad. But people were abusing this system. They just weren't interpreting it correctly. So now we have here's an idea of what your plate should look like, right? We call this the My Plate. 50% of your plate should be fruits and vegetables. A quarter of it should be whole grains, not processed grains. And a quarter of it should be lean proteins. And then because it's the United States, we love milk in this country, dairy. I swap this out for water. In my opinion, you're going to be in much better shape. And then put a little bit of healthy oils on your food, right? A little bit of olive oil, right? Great, super healthy. So we do have food labels to kind of help us interpret this information. The FDA, the Food and Drug Administration, is responsible for that. It is going to help us label our foods in ways that we have to understand. When it comes to reading a nutrient label, right? The nutritional quality, or at least the nutritional attributes, will be listed there. We call that the nutrition facts panel, but there will also be an ingredients list. You have a right to know what is in all of your food. So if we take a look here, you can see this is the nutrition facts panel. It will list the calories, fats, in saturated and trans. So you might notice the math doesn't add up. It's 0 and 0. It's but it has 1 gram of fat. Yeah, that must mean that it's unsaturated fat. Unsaturated fat is healthy, so they don't feel like they need to label it. Cholesterol, sodium, carbs. Carbs will be split into fibers, which again will not be absorbed, and sugars, which are not necessarily that great for us. But now you can see that would leave about 11 grams of carbs. That means that there's 11 grams of a starch in here. And then 4 grams of protein. Now, most important thing to pay attention to in a nutrition facts panel before you read anything else should always be the serving size. So the serving size is 1 slice. This is probably a slice of bread. And there are 20 servings in container. So, probably 20 slices of bread in there, right? That's where people are they'll look at my mom, she's look at a bag of potato chips and she's it's only got 90 calories. And it's 90 calories per serving. There's 4 servings in that bag. That's 360 calories. She's like, what? Yeah, always pay attention to the serving size. It's the first thing you guys should always look at. Now, it will have an ingredients list as well. Here's how ingredients lists work. It will always list what food is, or what thing is most present first, and then what thing is second, based on the weight. So I don't know what this food is, but it has enriched and bleached flour. That's what makes up most of it. This is probably pasta, if I had to guess. Wheat flour, malted barley flour, ascorbic acid, dough conditioner. Yeah, or dough. Oh, it's probably like a bread product. Niacin, iron, thiamine, right? All of that is what was present in the flour. Next ingredient, most in heavy, is sugar. Next one is cornmeal, salt, baking soda, honey, and then natural flavor, freaking natural flavor. That's actually ingredients that are so small that they're just allowed to call it that, and you have to kind of guess what that is. I never trust it when I see natural flavor because I don't get to know what it is. So on a nutrition facts panel, always pay attention to the serving size and servings per container. Take a look at the calories, fat, cholesterol, carbohydrates, fiber, sugars, proteins, vitamins. And then when you're seeing these percentages over here, those are based on a 2,000 calorie diet, which meets the needs of about 50% of the population. So, you know, again, that would be good for most people. A lot of people in this room, though, need more than 2,000 calories per day, you know? And maybe some people need less than 2,000 calories per day. So on a 2,000 calorie per day diet, we need about 65 grams of fat. As why 1 gram is only about 2% of your daily intake. 20 of it should be saturated. So again, remember I said 10%. So 2,000 calories times 0.1, that's 10%. That's 200 calories divided by 9. That gives us about 22 grams of fat. So they rounded it down to 20. But this person would be allowed, it's about 10% of their intake. 50 grams of protein, 300 milligrams. So these are all based on a 2,000 calorie diet. You might need more than that, guys, or you might need less than that, depending. Now, there are nutrient claims that you're going to see on foods. These do not have anything to do with the actual food. So when you see something say low fat, reduced sugar, high in fiber, right? You'll see stuff like nutrient claims on a food, right? So this says low fat. What does that mean, low fat? What's your definition of low? You know, they don't have to define it. They're allowed to say whatever they want. Cheerios, right? Made with 100% whole grain oats. Okay, cool. Now that's a good label. You know, I believe it, right? But then here it says, can help lower cholesterol. It can, because it has some fiber in it, right? So you'll see nutrient claims all the time on foods, and people will interpret that. They're allowed to say whatever they want on the front. That's not part of the FDA. That stuff is not regulated, right? Certain health benefits, you know, the FDA strictly regulates certain health claims, but those ones, they don't have to do it. This is why you'll notice every supplement you can buy. So like, here's like a multivitamin that I use, like, and it says these statements have not been regulated by the FDA. So when it says this can help with osteoporosis, right? It hasn't been approved by the FDA. So they can just say that, right? I could put together like water pills and say, may help you get hydrated. I'm not necessarily lying, but I don't have to run it by the FDA. Supplements are not regulated. That's why they can say so much crap. And that's why often supplements are just bunk. They just don't work because they haven't been scientifically studied properly. So you'll see like dietary fat has been linked to like cancer, saturated fat has been increased risk of heart disease. Fiber has been shown to reduce your risk of cancer. Fruits and vegetables have been shown to reduce your risk of cancer. We'll be talking about all the positive benefits of good foods and all the negative ones about bad foods as we move throughout this course. So obviously we need to be able to, break all of this stuff down. One of the other things we're going to be talking about is psychologically, how do we get people to adopt these habits? We're going to use what is called the Transtheoretical model of change, or the stages of change model. Some of you guys might be familiar with that, but it basically describes how we move our clients through healthy eating habits, right? So if I said, Chris, I'm going to put you on a new diet today, and you're like, ugh, I don't want to start a new diet today, you would be in what we call the pre-contemplation stage, where you're not thinking about adopting a new habit. So my job is to get you to move from not thinking about it to thinking about it, to maybe testing the waters, to practicing, to doing it regularly. And that is the stages of change. It moves you through different stages. So we need to know how to recognize where our client is. This is where a lot of trainers screw up, and a lot of clients screw up. Like they're like, I'm ready for change. And then you evaluate their life and it's like, oh, you're kind of not, like you're not really ready for change because like you're not serious enough about adopting these habits. We'll talk about what that means later. I'll break that down. We have a whole day dedicated to it. That's the nutrition coaching aspect of things, helping people understand it's the psychology. And then next month, in like a couple months, guys, we're going to be breaking down the stage of change like crazy. And it's all about, when we say exercise psychology, that's what we're talking about, So we got to have a pretty good understanding of nutrition. Hopefully you guys are starting to see like all the pieces that we're going to be covering over the next few weeks. Food and beverages, we got our 6 essential nutrients: macronutrients, proteins, fats, and carbs; micronutrients, vitamins, and minerals; and then our most essential nutrient is going to be water, which will allow us to use all of the other 5. Without water, you can't use any of them. We are getting our recommendations. Like sometimes we're like, who made up all these rules? Where did these rules come from? Well, they're based on the DRIs, the dietary reference intakes. We've observed, we've studied, we've practiced. This is what we found. Could we be wrong? Yeah, maybe. We used to think the food pyramid was the best way to help people. Now we're finding the My Plate. And in 10 years, we could have something new. It's all based on what we think is working best. So our job as nutritional professionals, one thing I want you guys to keep in mind, we are allowed to be nutrition experts. We are allowed to give advice. We cannot prescribe food. And that is going to be very important. So that is a simple breakdown and overview of what we're going to be going over. Anybody have any questions today? They put the chat bubble on. All right.
No questions.
Cool. Love it. All right. Well, ladies and gents, I will let you all out of here and see you tomorrow. If you haven't finished your final, please try to knock that out at some point. Other than that, I'll see you.
Right.
Okay.
All right.
Later.
Later, guys.